Hello everyone and welcome to the webinar on mesh modeling, analysis and optimization for fabricated metallic structures. We are excited to have all of you here and thank you for joining on time. To maintain the audio clarity, all attendees will be placed on mute for the duration of the webinar. At the end of offer, we will unmute you and have a live Q&A session where you can also ask your questions directly. Do feel free to use the Q&A tab on your screen to ask any questions you may have during the session as well, and they will be answered at the end. I am Milan, the marketing lead at DEP, and I will be your host for the session. This webinar focuses on the tool sets that help build high-quality mesh for fabricated structures. Besides, we are going to demonstrate welding tools that offer significant time savings to the user. I would like to introduce today's presenter. The session will be presented by Ray Shani, who is the Director of Pre-Sales and Software Support at DEP, where he is responsible for global development of Meshworks and CAD Morphing. He has studied at Auckland University and has more than 17 years experience in CAE with a focus on NVH and product design. He will be joined on demo by Sridhar Bijala, who is a lead engineer responsible for global software support of Meshworks and CAD Morphing. Also joining in on the demo is Abhiram, who is a project and software support engineer at DEP, responsible for global software support of Meshworks. Now the webinar session will start and Ray and team will be taking over from here. Ray, the stage is yours. You can take over.
Respect to fabricated structures. We're going to have a detailed discussion here showing you how Meshworks can reduce your time savings for all your modeling up to about 30%. So basically, we're going to show a bunch of different demos as well as a couple talking points in regards to the scope of fabricated structures. So with that being said, I'm going to turn it over to Sridhar to give you the introduction of what the demo session is going to be for today.
Hi all, good afternoon everyone. Today our webinar is on Meshworks applications to fabricated structures. This will give us an opportunity to see how Meshworks can be applied across different industry verticals, which involves large and complicated fabricated structures. As a part of this webinar, we are going to see the following list of items which we are going to discuss in this webinar. To start with, we are going to discuss at the outset what all are the different fabricated structures which we are going to discuss in this webinar, and we are also going to see what are the different fabricated structures which we are going to handle in a wider scope, and to show you the value of Meshworks. And also we are going to see how the Meshworks helps in handling all the fabricated structures. So we also have a lot of advanced tools which helps in handling the heavy engineering models like farm equipment and farming and railway industries. So as a bigger picture, we are also going to discuss about the width and depth of fabricated structures, which expertise and experience DEP has towards fabricated structures. So along with this, we are also going to see some of the live demos which covers the modeling of railway assembly, and also some of the parameterization and morphing capabilities using Meshworks. And also we are going to discuss on some of the case studies which we have done at DEP. And to end the webinar, we are also going to discuss about the key value proposition of Meshworks out of this webinar. And let us quickly move on to the background of the fabricated structures. On the screen you can see some of the statements which are highlighted, which defines what is fabricated structure and how they are bended and assembled together to create an assembly. So which which in different segments like heavy engineering, let it be earth movers and farm equipment, or oil and gas, railways, light commercial vehicles, or medium or heavy commercial vehicles, and also even in power systems like hydraulic power systems. So all these industries, we have like fabricated structures, and it is very tough to model this kind of fabricated structures. So we have very advanced tools which can be taken care very easily. So let us move on to the scope which we are going to address in this webinar. So we are going to see how a quality model can be generated very quickly using Meshworks for the rail structures. And also we are going to see a parameterization optimization done for a heavy engineering performance, and how we can apply the parameterization applications to the heavy engineering optimization problems. And also we are going to discuss about the welding of fabricated structures. So in Meshworks we have very highly automated weld tools where a user can pick the components and he can specify whatever type of weld profile you need, and it can also be parameterized. So that is one more added advantage with Meshworks. And also we are going to discuss on some of the performance and weight optimization problems which Meshworks can handle. So now let us see what are the fabricated structures like DEP is working at, and if you see like in rail structures, user can do the modeling part. So right from the mesh generation, connecting the assemblies together, let it be a welding or bolt connections or whatever different type of connections can be done using Meshworks. And also farm equipment. So in farm equipment, if you want to quickly morph the shape of the bucket, or to even the farm the trailers which connecting to the farm equipment can be modeled using Meshworks. And also if you see the excavator, you can quickly change the shape of the excavator from smaller to big or big to small, and also the boom shape can be optimized to improve the performance for the excavator. And also in the oil and gas industry, the riser guards can be optimized by using the shape parameters, which helps in a better flow rate. And also in the shipping industry, we can optimize the position of the sections, and also the hull shape of the ship, which improves the performance of your CFD study. And if you look at the hydroelectric industry, like you have penstocks where the water will be driven from the hydroelectric power plants to the turbines. So all those huge pipes can be welded very quickly using advanced weld parameters in Meshworks. So this is how Meshworks is applicable in the railways. So using Meshworks, we can create high quality railway wagon rolling stocks and bogie models. And the best part of this is, like, when you model your mesh using Meshworks, it becomes parametric. So in the later stage, when you want to optimize your design, a user doesn't have to create any offsets, or he doesn't have to create any control blocks. So whereas in the older days, we used to create all these control blocks, which takes a lot of time. At the same time, a lot of experience and expertise needed to do such kind of operations. But using the latest technology in Meshworks, the mesh becomes parametric once you do the meshing. And this is about the parameterization and how we can apply to different fabricated structures. So again, you can create different parametric model. So if you already have a mesh generated from another software, you can still create parameters, let it be a shape, gauge, or material parameters, and you can optimize your models based on the, let it be a mass optimization or improving the performance. So different objectives can be studied at the same time. And this is about the welding tools in Meshworks, which helps the larger fabricated structures to merge together by doing the seam welding weldments. So here we have different types of welds, like let it be capturing a heat affected zone for your heat transfer, like weld propagation analysis, or let it be the ship sections welded together to form a single model, or let it be a welding penstock pipes in hydraulic power systems. So all these areas can be solved by using Meshworks weld process. So if you see the animation, you have different varieties of welds: concave, convex, and straight, and also heat affected zones. And also you can control the shape of the weldment by parameterizing it. And this is about the weight optimization by without degrading the performance of different industry models. If you see in this screen, you can see the boom of an excavator is parameterized using different parameters like shape changes and gauge change of a boom, angle change to the boom, and parametric changes for the reinforcement locations. Using all these different parameters, you can optimize your model, keeping the performance the same. And you can also do the multidisciplinary optimization using Meshworks as a preprocessor, making a parametric model. So you can link with any of the optimization softwares like Morphing, iSight, and VisualDoc. So with this approach, you can generate n number of designs by using a DOE approach, and you can generate your optimized design. And not just that, we also can handle the vibration problems, like if you have a acoustic cavity which need to be created in excavator or farm equipment cabin structures, a user can very quickly generate it just by using some simple buttons. So if you see, like you get lot of vibrations in the heavy farm equipment cabins when they are handling on the site. So using this acoustic cavity, we can quickly create acoustic cavity with having the connectivity to the body. So with this, we are going to look into the demos now, and Abhiram is going to take over.
Hello everyone, this is Abhiram, and the first demo that we are going to see today is the meshing of the railway trailer bogie. And here in Meshworks, we have different ways to mesh the CAD model. So we have basic mesher, where we can just select the surface and specify the element type and we can mesh it, or we can use an interactive batch measure option where we can just select the PID and then we can specify the template. So we have different templates for even for the mid-plane meshing. So we can just specify the template, and in the interest of time I have meshed the model beforehand. And so this is how the meshed model will look. And if you see, Meshworks has nicely captured all the features like the washers and even the rounded edges and the holes, and everywhere the model is meshed nicely. And so you see, with Meshworks using the interactive batch measure option, the meshing has been done nicely and all the features are captured. So in the background, what Meshworks does is, in the template, we can specify different meshing options such as the mesh type and the element sizes, min and max, and also for the fillets we can specify, for the tubes we can specify the min and max diameters, and the circumference, the number of elements, or we can give the element sizes even on the straight edges, and also we can give the washer, like concentric washers. And similarly for the fillets we can give the min and max radius and values, the widths, and based on these values it will automatically identify the fillets. Similarly, even for the holes we can give the min and max values and also specify the washer sizes. And we can also give the quality criteria for 2D mesh such as the triangles, quad angles, warpage, Jacobian, etc. And even for the 3D elements we can give the criteria such as TET collapse, and we also have some advanced meshing options for the tetra mesher. And based on these, the user can take a predefined template, or he can define his own template and make the required modifications. And so this is the sheet metal midplane, automatic midplane meshing. So similarly, we can also mesh a casting component like you see here. So we can specify the different template, and based on that Meshworks will automatically create a tetra mesh model, and also it will identify the features such as fillets and some walls. And so the one advantage of using Meshworks is that once the model is meshed in Meshworks, the model becomes automatically parametric, and there is an associativity maintained between the mesh and the CAD. And so we have some auto tools such as the auto parameterization. So here we can directly change the values of the fillet radius and vary the wall height automatically with very few inputs. For example, if we have to change the height of this rib, so the user can just select the face of this rib and specify the deformable layers and the range which he has to modify, and just click on execute. So in the background, Meshworks creates the process of creating the morph sets, and it will define the direction and to create the parameter. So with just couple of inputs, we can create auto parameters. So if you see, the status is done, and once it's done, we can click on review parameter. And we also have some sensors. So once we link this parameter that I just created, so before making the change, we see that the value is 0 on the sensor. So as we morph this rib height in real time with the help of this sensor, you see this value is changing, and it will help us to understand to what extent we are morphing. So this tool comes very handy if the user wants to, while defining the parameter itself, he can understand to what extent he can morph, and based on that he can make the necessary changes. Similarly, the user can also change the fillet radius. So for example, so in this location, so we selected this set of elements, and you see the baseline fillet radius is 25 millimeters on either side of the fillet that we selected. And when we make the change, right now this is the baseline model, and when I want to reduce the fillet radius, you will see that the fillet radius value will change in real time, and without having to measure it manually, it will automatically, the value gets updated here, and the neighboring mesh also gets adjusted accordingly. So this is the advantage of using auto parameterization even for a casting component. Similarly, the user can also create parameters for changing the tube diameter and also rib thicknesses. And the next demo that we'll be seeing is on the seam weld. So where we have like a thick sheet metals, sometimes they are modeled, instead of shell mesh, they are modeled even as a tetra mesh. So if we want to create a seam weld between these two components, so after meshing, even in Meshworks, connections such as seam welds can also be created with very less inputs and also effectively. So there are different ways to create the seam welds. So let us select the 1D elements option, and so there is a 1D element which is created here in between these two parts, and if I just select the 1D elements, and I need to specify the master, which is this component, and the slave is this component, and there are different inputs that we can give in the weldment input dialog. So we can specify the weld width, the width of the weld that we are going to create, and also the element size along the weld length of the weld, and the number of layers along the weld width. And not only that, but also the profile of the weld can be changed. It can be flat, concave, convex, etc., which we'll see in a minute. For now, I'll just demonstrate the flat weld. So the weld type is flat, and here there are different ways to in the align type we can use the merge nodes or coincide nodes or coincide non-coincide with contact. If we create merge nodes and preview the weldment, so the weldment has been created, and here since I selected the weld type as flat, you see the profile of the rib is flat, and also it's a 3D tetra weld. Similarly, I can create a different weld type. Say for example, if I select concave and preview it, now the profile of the weld will be concave, so it's slightly inward towards the model. And or I can select convex, and also I can also select tapered weld. So now it has created a tapered weld at the ends instead of creating a normal weld, and here the profile is convex, as you can see. And we can also give a heat affected zone can also be created here. So in addition to creating the weld, heat affected zone can also be created automatically in Meshworks. So here, just to recap, we have so once we started with selecting the 1D elements on the model where we want to create the weld, and then we specified the master component and the slave component. Then in the solid weldment inputs panel, we specified the number of parameters such as the number of layers in the weld, the element size, the element width, and also the profile of the weld. And then we gave the align type as merge nodes, and also we selected the heat affected zone option, where Meshworks will create the weld and also create a heat affected zone with good node to node connectivity between the two components and also the weld. So this this automatic process will take just a minute, and if the user has to create it manually, so it would take about, if there are like multiple 3-4 regions where the user has to create a weld like this, it would take about 8 to 12 hours of time, and where here in Meshworks with this feature, we are able to create it within a couple of minutes.
This particular weld type is a weld type used in a software called Verity. Okay. In Verity software, it's required that the heat affected zone be modeled with the foot and the toe. As you see here, the green and the yellow are just basically going to highlight the weld. But now, once he changes the colors and he's going to turn off the components, you're going to see how it's nicely modeling the foot and the toe and the side end caps of the weld. So this kind of heat affected zone modeling is used for Verity software, just to be clear.
So here the heat affected zone has been created, and also a node to node connectivity is maintained, and the user it's a readily runnable FEM model. So this process saves a lot of time and it's efficient. Within less time, we can the user can model this seam weld with the heat affected zone, and this is very important in the crack propagation analysis. And the next demo that we'll see is on the boom for the heavy excavator. So here we'll see some shape changes. So when we link the parameters, so we can vary the thickness of the side walls. Similarly, even on the other side, we can vary the thickness. So in this excavator, this is the boom and this is the arm. So we are seeing the shape changes for the design of the arm, sorry, the boom. Now for the bottom half, the bottom plate thickness can also be changed. Then the user can change add or remove more material on this side to change the stiffness of the component in the local region. And when we make this shape changes, automatically the neighboring mesh gets adjusted, and it's very user friendly. So similarly, even on the other half, we can add or remove material. Then we can also change the fillets. If you see, we can change the angle of the surface by just moving this in either direction. We can also rotate this whole end of the boom connection, whether it is the left end or the right end. So all these changes have been done using the control block morphing technique. Now we can vary the width of this entire boom section on either side. Individually we can have control, or we can just create one parameter to change the width on either side. On the baseline boom model to get a completely new design within very less time. Similarly, for the arm, so even for the other arm, we can create control blocks, and also if you see this animation here, we can vary the thickness of these walls, and we can increase or decrease the width of this member, and we can add the beads for stiffness in the local regions, and with very few inputs we can create those parameters. And the next demo that we'll be seeing will be the morphing on the ship section. So we can create some sectional changes. So if you concentrate on this area, so we are moving the whole section of the ship hull cross section. Similarly at this end, and also we can add or remove more material on this wall, or we can also change the radius of this hole in the hull section. The radius of the hole and the hull can also be changed.
Hello. So based on the demos like Abhiram have demonstrated to you, we see like there is a lot of scope, and you can use Meshworks in handling fabricated structures and heavy engineering. And to address the key value proposition of Meshworks, using Meshworks you can drastically reduce the model building time, because whatever models which we were demonstrating today, everything was built in Meshworks in no time. And also all the mesh building tools also, it's kind of a automated process, so a user doesn't have to spend any manual efforts. Or even parameterization or morphing capability is also kind of a automated approach, so a user doesn't have to spend time in creating everything manually. So using Meshworks, we can save a lot of time when it comes to process automation. A general CAE modeling or assembly or any kind of activity can be automated by using the process automation module, which could save 2 into 10 into times that time you're taking with the present workflow. And also the parametric CAE mesh modules helps to optimize your fabricated structures by reducing the mass and also improving the performance of different problems. So with this note, like we are open for the questioning.